Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with orthographic front view, top view and the right hand side view projections in such a way that we are required to club the information which is provided to us through these three orthographic projections over here into a single 3D isometric projections of the solid over here. So now with the information which is provided to us, now we need to evaluate the isometric projections into the 3D construction in which the front face, the right hand side view face and the top view face corresponding to this engineering object, it needs to be clubbed into a single 3D isometric projection. So for that, we need to evaluate the dimensions of the front face, side view face and the top view face over here. So now if we look at the orthographic projections of this engineering object, now we observe that the length of the object happens to be 60 millimeter and the height of the object happens to be 50 millimeter. So this is going to be our front face. So along the XY isometric axis, we are going to obtain the front view projections corresponding to this face of the object over here. So now we can check the front view face. It is going to measure 60 millimeter by 50 millimeter and the projections will be drawn onto the XY plane over here. Then we have got the top view face, so we can check into the top view face the length will be observed as 60 millimeter, whereas the width of the solid will be observed as 50 millimeter. So we can check into the top view projections, 60 millimeter will be the length of the solid while 50 millimeter will be the width of the solid. So into the XZ plane, so this is going to be Z axis, this is going to be the X axis. So alongside XZ plane, we are going to obtain the projections corresponding to the top face of this engineering object over here. Next we have got side view face. So here we are going to observe the right hand side view face over here. So into the right hand side view face, we will be obtaining height is equal to 50 millimeter and the width will be equal to 50 millimeter. So into the right hand side view face, we are going to obtain width equal to 50 millimeter and height will be observed as 50 millimeter. That is alongside the YZ plane over here. We are going to obtain the right hand side view projections into the 3D isometric projections over here. So now we can see alongside X axis the length will be depicted, alongside Y axis the height of the solid will be depicted and alongside Z axis we are going to depict the width of the solid over here, and all the dimensions which are available with us into these orthographic projections, so they need to be converted using this isometric scale into the isometric length dimensions over here. Once we are able to convert these true length dimensions from the true length scale into the isometric scale, so only then we will be starting with the construction of the isometric projections of this engineering object over here. So now let us proceed with the construction of isometric projections of this object. In order to obtain isometric projections, now we are going to start with the construction of the isometric x-axis alongside which the length dimensions of the solid they will be projected over here. This is going to be the Z dimension into which the width of the solid it will be projected over here and the height of the solid will be projected alongside this isometric y axis over here. So now let us start with the construction of the isometric projection. So this is going to be our front face. This is going to be our right hand side face. And this is going to be our top face over here. So first of all, without bothering about the constructional details of this object, we are going to obtain a cuboid construction over here, which is going to depict the front face, right hand side face, and the top face of this engineering object over here. So we know that the length of this object, it measures 60 millimeter. So this is the length of the object which we have observed into the front view projections over here. So we'll be converting this dimension into the isometric length. So whatever isometric length is obtained, so this will be projected alongside the x-axis over here. Similarly, we are going to measure the width as 50 millimeter. So here we have been provided with width of the solid is equal to 50 millimeter. So this width has been provided alongside z-axis over here. So now once we draw this projection line, which will be parallel to the z-axis over here, and again when we draw this projection line, which will be parallel to this x-axis over here, and now we'll see that this isometric length, this will be measuring 50 millimeter, and this isometric length will be measuring 60 millimeter. So the top face of this engineering construction, it has been obtained over here. So now we know that the height of the object happens to be 50 millimeter. So this is the height of the object which we have observed into the front view projections as well as into the right hand side view projections over here. So once we know this is the height is equal to 50 millimeter, now we are going to complete the front view face construction of the solid over here. So the front view face, it is going to involve length is equal to 60 millimeter and height it is equal to 50 millimeter. So now we have drawn two isometric edges over here. So this isometric edge, it will be measuring 50 millimeter and it will be parallel to the axis over here. And this isometric edge, so this we have drawn from this point, and again this will be measuring 60 millimeter and it will be parallel to the x-axis. So this way the front face construction of the solid we have obtained over here into the isometric projection view. Now let us complete the right hand side face construction of this particular solid. So we know that the side face is going to measure 50 millimeter by 50 millimeter. So 50 millimeter happens to be the width which will be available over here, and 50 millimeter height, it is corresponding to this front view height which we have been provided over here. From this point again we are going to draw an isometric projector, and this isometric projector is going to measure 50 millimeter and it will be parallel to the y-axis. And another isometric edge or the line we have drawn over here which is going to measure 50 millimeter and it will be parallel to the z-axis. So this way the right hand side view face of the solid has also been completed. Now let us complete the top view face. So in order to complete the top view face, now one isometric edge we need to draw parallel to this line or parallel to this x-axis over here, measuring 60 millimeter. Another isometric edge we have drawn over here which is going to measure 50 millimeter, and this isometric edge will be parallel to this edge over here or it will be parallel to the z-axis over here. So now we have to complete the height corresponding to the rear face of the solid. So corresponding to the rear face, once again we have drawn a perpendicular projector line in such a way that this vertical perpendicular projector line or the isometric edge, this will be parallel to the y-axis and it is going to measure 50 millimeter, that is the height of the solid over here. So this way, into this isometric projection construction, we have been able to obtain a cuboid block in which the front face corresponding to the solid has been obtained, the side face corresponding to the solid has been obtained, and the top face corresponding to this solid has been obtained over here into a single isometric projection construction over here. Now let us try to fit in different elements which are available with us corresponding to this engineering object into this isometric projection over here. Now as we are going to observe this orthographic construction into the front view projections, into the side view projections, and into the top view projections over here. So two things we are able to observe over here. Here into the solid, we are having a lower web over here. Please check. This is a lower web or a bottom web which is available over here, which is visible with us from the front view, and this bottom web or a lower web, it is visible with us from the right hand side view. So we know through this construction that into this solid at a height of 15 millimeter, there will be a horizontal web which is going to lie into the front face and into the right hand side view face over here. And now while this lower web or the horizontal web, it is there at a height of 15 millimeter from the base of the solid, but this horizontal web, it is going to turn like this as we are able to visualize this from the right hand side view construction over here, that this horizontal web, it is going to move along this vertical path towards the end of the solid, that is this portion of the solid, it will be going vertical, whereas this portion of the solid, it will be having a horizontal web over here. So this horizontal web, it will be changing the direction into the vertical web towards the back side of the solid over here. Another thing we can observe through this orthographic construction over here, as we are going to look at the solid from the top. So this web which is going to be there at the back end from this side, it is going to turn towards left hand side as we are going to move towards this side of the solid, that is towards the left hand side of the solid. So one vertical web we are going to encounter towards this portion of the solid, and this vertical web, it will be changing direction over here. So this way towards the back side there is going to be a continuous web, and from the horizontal side there will be one web over here. So let us start construction of this particular engineering object into the isometric projection. So as we have discussed, at a height of 15 millimeter, there is going to be a horizontal web which will be visible to us from the front view, and it will be visible to us from the right hand side view over here. So corresponding to this horizontal web which is having thickness is equal to 15 millimeter. So we have marked a thickness of 15 millimeter over here. So now we have drawn two isometric projection lines in such a way that this isometric projection line will be parallel to the x-axis. This isometric projection line, it will be parallel to the z-axis over here. Now this height we have maintained as 15 millimeter. So now we can see as we are going to look at the object from the front, so this portion of the web will be visible to us. So this portion of the web, it will be visible to us from the front side. Up to what length this web will continue? This web length will continue up to the distance of 36 millimeter from the right hand side corner. That is from this point, if we move along this particular dimension, that is alongside x-axis, so this web will be available with us up to a distance of 36 millimeter over here. Similarly, one more thing we have observed into the right side view. So this horizontal web which is going to continue up to 36 millimeter. So here in the right hand side projections we can check this web, it is going to turn vertically upwards over here. And what is going to be the thickness of this web from the right hand side view projections? So the thickness of this web, it will be equal to 15 millimeter. So we have marked the thickness of this web. So we can check this web from the right hand side view, it is going to change the direction, and it is going to move into the vertical direction, and this thickness of the web will be equal to 15 millimeter. So once we mark this thickness is equal to 15 millimeter, another isometric projection line we are going to draw, which is going to fix the thickness of this particular web into the top view projections over here. We can check into the top view projections. So this thickness will continue as 15 millimeter, and this thickness will continue as 15 millimeter up to which distance? It will continue up to a distance of 36 millimeter over here from the right hand side face over here. So from the right hand side face, so this thickness of this web equal to 15 millimeter, it will continue up to a distance of 36 millimeter. And what will happen after that? After that, this vertical web, it will be changing direction into this vertical orientation over here, that is into the perpendicular direction over here. So from a point which is located at a distance of 36 millimeter from the right hand side face of the solid, now we find that this vertical web, it is going to change the orientation by 90 degree, and now another vertical web will be there which is going to move towards the front side of the solid. Now it has changed the direction and it is going to move 90 degrees, so that this web which was located onto the rear side of the solid, now from the rear side it is going to move towards the front side of the solid over here. So this vertical web measuring 15 millimeter thickness, now the thickness has increased up to this point over here. So what is this location of the point? So we find that this distance, it will be equal to, we can check, this is 15 millimeter. So this step which we can see over here, so this step which we can see, it is measuring 15 millimeter width over here. So this will automatically be 20 millimeter. So up to a distance of 35 millimeter from the rear side wall of this solid. So 15 millimeter is this distance, will measure another distance of 20 millimeter, so that from the rear side, so up to a distance of 35 millimeter, so this web will be continuing straight away, and then there will be a step over here which is going to have a height of 15 millimeter and again a width of 15 millimeter over here. So now we can check, we have marked this web equal to distance of 24 millimeter from the left hand side, because the total length of the solid happens to be 60 millimeter. So this web 15 millimeter thickness which is located towards the rear side of the solid, it is going to be extended up to 36 millimeter. So this remaining distance will automatically become 24 millimeter. So now this web has changed the direction, so that now this web is going to move towards the front side of the solid over here from the rear side of the solid, and then it is going to move 35 millimeter from the rear side, and then into this 15 millimeter width we are going to have the height of the step is equal to 15 millimeter, and again the width of the step will be again 15 millimeter. So now we can see over here we have formed the step over here from this isometric projection line which is going to measure 24 millimeter. This will be drawn parallel to the x-axis. We have drawn two vertical isometric projector lines over here parallel to the y-axis, indicating the height of the step. So the height of the step will be equal to, we can check over here, it is equal to 15 millimeter. So this 15 millimeter height we have marked from a distance of 35 millimeter from the rear side. We can check over here. So this is a distance of 35 millimeter from the rear side. We are going to move 15 millimeter because this height has been provided to us as 15 millimeter over here. And now the horizontal projectors we are going to draw over here, that is corresponding to this width which is equal to 15 millimeter. So this is 15, this is 20, and this is 15. So this 15 plus 20 plus 15, it makes it 50 millimeter as the width of this solid over here. So now we can mark this height of this vertical step over here as 15 millimeter. So this way, this portion of the web we have been able to obtain. So now we can see this is a web which is going to extend from rear side to the front side of the solid, such that the width of this web happens to be 24 millimeter, and at a distance of 35 millimeter from the rear side, it has encountered an intersection with the cutting plane in such a way that we have got a step over here in the downward direction where the height happens to be 15 millimeter and the width of the step also happens to be equal to 15 millimeter. And now if we join, we can check from this point a vertical projector we draw, and from this point again we draw a projector. Now we can see if we are going to look at the solid from the front, so this is the vertical face which will be visible to us as a true shape. So here we have encountered a vertical true shape over here. Similarly, if we are going to look at the solid from the front, so this vertical face, it is visible to us from the front side. And now there is an L-shaped web which is visible to us from the front view projections over here. Similarly, from the right hand side, we can check this is the L-shaped web which is visible to us over here, and corresponding to this portion, again an L-shaped web, it is visible to us from the right hand side over here. So these are two L-shaped webs which are visible to us from the right hand side. Similarly, from the top view construction, we can see this is an L-shaped web which is visible to us from the top view projection, and again this is a rectangular true shape projection corresponding to this step which is available with us from the top view projections over here. So now all the three faces, now we can check, we have verified into this 3D isometric projection construction over here. So let us join all the faces of this solid which will be visible to the observer. So as we have discussed, this is an L-shaped web which is visible to the observer, and then from the right hand side, if we can see, this is again an L-shaped web which is visible to us from the right hand side, and from the top view face also we can check now, this is L-shaped web which is visible to us from the top view projection. This segment is 36 millimeter by 15 millimeter, whereas this segment, it happens to be 24 millimeter by 35 millimeter over here. So as we join this portion of the solid, now we can see over here that this is the, as we join this portion of the rear side web over here, so now we are able to see a rectangular portion or a projection into the front view projections measuring 36 millimeter. It is the length of this particular rear wall over here, and the height happens to be 35 millimeter. And now we have to join this step over here. So in order to show the step, so we have joined this portion. Now we can see this width of the step, it happens to be 24 millimeter, and the height of the step, it happens to be 15 millimeter over here. And from the top view we can check once again, this width of the step, it happens to be 15 millimeter, while this length of the step over here at the base, it happens to be equal to 24 millimeter. So this is 24 millimeter, this is 15 millimeter. So this way, now we have been able to convert the three orthographic projections which were available with us into a single 3D isometric projection construction, in which the three faces, that is front face, the right hand side face, and the top view face, it has been obtained into a 3D isometric projection construction over here. I hope that through this discussion you would have understood about the procedure, how we can proceed to convert the orthographic projections into the isometric projection over here. This is all for today. So we will be continuing with further discussion regarding few more illustrative cases of the isometric projections in the coming lecture series discussion over here. So thank you very much. Thanks a lot.